Hey guys, welcome back to AlgoYogi. We are doing array and hashing series, and next problem in the list is design hash set. So let's go to LeetCode, and as the title says, it's a design problem. So we'll be designing the class myHashSet, and here are the methods that we need to implement. So we already know like how a hash set work. Basically, it's a collection of values and which contains distinct values, and then we can add values to it. We can remove values to the hash set from the hash set, and then you can check if it contains some value in the big of 1 time complexity. So so design a hash set without using any inbuilt hash table libraries. All right, so they're not asking that don't use list, or they're asking any hash table libraries. So now, and we need to implement myHashSet class. So first would be the add method, which will take in a key and inserts that key into the hash set. Then contains method returns Boolean value true or false if the value exists inside our hash set. Then we have remove functionality, so which removes the key, the value from the hash set. If it doesn't exist, then you do nothing. Well, okay, so let's go over the constraints here. I think the constraints here are that the key will be in the range to 0 to 10 to the power 6, and at most there will be 10 to the power 4 calls. So that means there will be at most at a time 10 to the power 4 number of values present. So basically 10,000 values max will be present at a time. So we need to implement this class right here. So a simple way, brute force way would be, and in this case which might work even, so they're saying that the values would be in the range 0 to 10 to the power 6. This is the values range, right? And then 0 to 10 to the power 4, this is the range of so max number of vals at a time, which means that this is the number of keys will be present. So that will be the total size of our set. And if we are choosing to use basically an array, then we can use this value to create that big of a list, and then the index would be that key, and that at that index it would store that value. So let's say if I can create my hash set. My hash set right now just can contain an array, so I'll just call it array, and it will be of size initially, let's just add 0. That's it. And then when we are adding, we will just add it to that index. If we can check like if it already exists, then sorry, my bad, it's not the 0, it's to my array. I will check if it exists or not. I'm talking about the brute force solution here, so I don't want to go into too deep here, but you can just you can mod it with 10 to the power 4 and then store that key right here. You can do the same thing from here. You can just remove this this particular value, this key, and then contains if basically at array key 10 to the power 4. So I'm just modding because the range of keys is 10 to the power 6. So but at max there will be 10 to the power 4 number of values present. So you want to just loop in again. So you can just mod it with 10 to the power 4. So if that key is in array, then return, otherwise no. So that is a very simple and brute force way of solving this problem, and I think you can write the solution and it will work. But in a real scenario, you would want to take care of the collisions, and I think in this case we were taking care of collisions, but we were guaranteed that the number of values would be in this range. Then what I can do is, because it's all about handling the collisions, the best way of handling collision is how about at a particular key you create a list node, and if again you come across a key that lands on an index where there's already a key present, then rather than overriding it, you append that key, new key, next to that. So such that later you might want to check if it contains that key, then you can just do a linear search, or more optimally you can do even a binary search or whatsoever, but like in linked list, I think it's better to do a linear search. So we can use linked list in such way that it will handle our collisions. So what I'll do is I will create an array which will be basically, it will have, you know, this. So let's say these keys are the indexes, and here it will be the list with list nodes. So let's say if I'm adding 1, so I will add it 1, and here I will create list node with the value 1. But remember, this is just one node, and then in the second there will be something like this. But then let's say if I were adding some other value again, in this case it's just integer values, so it wouldn't be like a big deal, and we will never have, you know, 2 duplicate values or keys, because otherwise we already have that same value. But let's say if we are adding some string values, or there was like a hashing function that will give us the key. But then let's say if I got another value for the key 1, then I will just point this current head, it will be head in this case, head dot next to this I will append that another value, list node. And in real scenario, like it would look something like, initially I will have a 0 node, this is a dummy node, then I will append this value, and then this will have, let's say, some hash or something. So let's go ahead and implement this. It's going to be, so just think of it as a regular array, but instead of just one value, it points to basically a list node. And a more appropriate representation would be if I just draw, let's say, this is, I create this array, and it will have all these indexes, 0, 1, 2, 10 to the power 4, and then from here this 0 will be pointing to a node. So this is a list node class, and this list node class will have a value, and then it will have the next pointer, right? Next pointer. So we can assign these values. So for each node there will be a value and next pointer. So let's say if I was trying to add some value to my hash set, then, and initially, like if the key was supposed to be 0, initially we'll be calculating this key by modding it with, the key will be given to us, and we will just basically mod it with 10 to the power 4, because that's the total max number of values present to us. So let's say if I were adding 4, then 4 mod 10 to the power 4 will give me 4, which means at here somewhere this will be pointing to a list node, and then here I can try to traverse if there might be other values already present. Then I will just like place it right here, and that's it. And next time if I were checking if 4 exists here, then I will again check for that key. I will go to 4, and then from here I will start checking linearly if 4 is in this, because it will be more like a list, right? So I'll have to keep going, use that iteration, if cur.next, and keep moving that current pointer to the next value. So this will be of you can say most of the time, ideally all these add, remove, contains, they should happen in big of one time, but worst case they might be big of n time complexity, and n could be 10 to the power 4, and the reason is there will be max 10 to the power 4 number of values present, and what if we keep getting the same key again and again, although the reason we are implementing it with list node so that we can avoid these collisions, right? So let's go ahead and implement this. All right. Okay, so before I dive deep in here, I'll just create a class called node or list node. You can call it class list node, which will have the key, and one thing is value. List node contains a value, so value, and then self.val is value, and then self.next is, initially there is nothing next, but this will be pointing, it's of type list node. Then here I would say self.set is going to be equal to, like, I'm gonna have an array, but I'll create a list node. So list node with 0 value. This is the dummy node that we're creating for we can just say in range, and the max number of keys that will exist is 10 to the power 4. So that's it. That's all when you're creating a set. So remember, like, a lot of people, what they do is, like, they put it like this and then try to multiply 10 to the power 4. That will not work, because it will just copy the same node onto all the 10 to the power 4 places. So that's what you don't want. You want to have it this way. This is the better way, because you're iterating over that many number, and you're creating a separate copy of this. Now it's about adding a value. So first of all, you want to take the current node, which is the dummy node, right? You want to pick it from where you will be getting it from self.set, but here you will be providing in the key, but this key could be more than 10 to the power 4, but that's the total number of values. So just we're going to mod it with 10 to the power 4. So 10 to the power 4, this will give me that key after we're taking the mode of the key. Now I have this cur, while cur.next, then there might be a lot of values present already on that key. So I want to keep pushing this cur.next to cur.next. Once I reach a place where this current is pointing to a value, but next there is no other value to the next of it, so I will just append that. So cur.next is this value, this key right here, but of course it's going to be also a node, so list node, and let's provide that key. There's another thing is, like, what if that key already, that value already exists, right? So we can check right here. So if cur.next.value is equals to the key that I'm trying to store, then I can just return and do nothing, because it's already stored, right? I don't want to, like, do the repeated work. That value already exists in my hash set. I don't have to do anything. I can just return simply. I don't have to return true, false, or anything. Then what about remove? Well, remove will also follow the same logic, but this time we're trying to look for the value. So while cur.next exists, then if cur.next.value is equals to key, rather than returning here, and of course we are not storing, so I'll remove that, current.next. So if that's the value equals to the key that I'm trying to remove, so cur.next, I will skip that value. So cur.next would be cur.next. Either it could be some value in the middle, so I'm just skipping over that value. right? And another thing is contains. Well, contains is also, you know, gonna follow the same logic. I have current, then while cur.next, and if this is equals to, you know, this value, then I return true. Keep moving forward, then I want to return false, right? If that value doesn't exist. Otherwise you look for it. If it exists in your set, then you basically return true. And let's not forget, when you basically move this pointer, you know, you skip that pointer, we need to return from here. We don't need to return true or false, but just return it. Otherwise you'll keep, you know, going over this value. So I think let's zoom out and then let's run it. Awesome. Let's submit. Great. So now let's talk about the time and space complexity. Well, the space complexity is, you know, for the entire set, you know, space complexity for the entire set is like, let's say, big of 10 to the power 4. But for time complexity, like if you were not taking care of, you know, through this linked list list nodes, this chain of list nodes, we are chaining to remove these collisions. In an ideal scenario, if each key is mapped to just one list node, then it should be big of 1 ideally. But since we are having these while loops to look for that current value, like worst case, we have to like write big of n is the total number of you know, the keys in one. I'm not writing 10 to the power 4, I'm just writing n, and that n is the number of nodes in one key after, like, let's say, significant collisions. That's the number, and it could go worst case to 10 to the power 4. So now let's go to AlgoYogi, mark this problem solved, and see you guys later in the next problem.